Video lesson 9.5. This is a trigonometry topic in geometry dealing with cofunctions. So cofunctions, we talked briefly about them at the beginning of the unit, but cofunctions, again, are a special relationship between two different trig functions. All right, so if we're looking here at this particular triangle here, which I have as triangle ABC, so we've got our sides here. And that this diagram is labeled little a, little b, little c to represent the lengths of those sides with respect to those angles A and angle B. And as you can see here, C is our 90-degree angle. So we've got our hypotenuse at C, we've got our legs at A and B. So the question states here, given these angles denoted by this symbol here, which again, if you don't know that symbol, it's the alpha symbol, Greek letter alpha, and that shows that acute angle. And B is denoted with this symbol, which is beta, the Greek letter beta. All right, so those are just the two things symbolically, so you understand what those symbols look like. And then the other thing, just to remind yourselves, all right, we all know what these trig functions are, but let's just write them out. Sine is equal to opposite length over the hypotenuse's length. That's the ratio. So the sine of the angle we're referring to. And then cosine of the angle is going to equal the adjacent side over the hypotenuse. Okay? So if we use those two trig functions and their relationships, let's write out here what each of these things is going to be. So sine of alpha. So here's A. So with respect to alpha, or angle A, right, we've got opposite, hypotenuse, and adjacent. So if I was to go to write my ratio here, sine of alpha, as they have here, would be opposite, which is A, over hypotenuse, which is C. And if I go and say that with respect to sine of beta, which is this one here, right, we've got sine, so this would be opposite then. This would still be hypotenuse, and this would then be the adjacent side. So with respect to beta here, sine would equal opposite over hypotenuse, so B over C. So if I go back to cosine now of A, so I'm going to go back to this scenario over here, right? Cosine of A, here's A again, so that's the adjacent side over the hypotenuse, so that's B over C. Well, notice I get two answers that are the same. And if I go and I do the same thing for cosine of beta, which again is this angle here, I'd have the adjacent side over the hypotenuse, so that would give me A over C. So when we do this, right, we notice that sine of alpha and cosine of beta are giving me the same values, and sine of beta and cosine of alpha are giving me the same values also. Whatever those lengths are, they would end up being the same fraction, the same relationship. So it's not a coincidence, all right, from here. So sine and cosine, they are called cofunctions, which means, right, sine and cosine are cofunctions. So this means that when the angles, that didn't come out very nicely, when the angles are, or I should say equal, the sum of 90 degrees, the two trig values will be equal. So what does all of that mean? All right, let's look at the picture here down below. So the thing that you need to remember is cofunctions, right? Cofunctions and their complements, right? What's a complement? Again, the other number that adds to 90 degrees, right? From here. So in this particular example, right, this gives me one angle here of theta, an unknown angle, and 90 minus theta would be the other angle. This would be its complement, all right? So the complement of theta is 90 minus theta, because it's whatever the other number that gets me to a sum of 90. So if sine of theta, so sine of some angle, right, it will always be equal to, if you take the other trig function, its cofunction, which in this case is cosine, if you take its complement, those values will end up being exactly the same value, right? And you can check this, right? So let's just do a quick one here, right? So if I said to you, what is sine of, let's say, I don't know, let's say 30 degrees, all right? If you took your calculator, if you type in your calculator sine of 30, right? Or if you use your reference table, you'll know that this equals 1/2, right? Well, since I know that, I also know that the cosine, of its complement, so the complement of 30, meaning aka what number do I have to add to 30 to get to 90, that would be 60, is also going to be 1/2. And again, you can check this, go into your calculator, hit cosine of 60, hit enter. You'll see that both of these things end up being the same. Again, these are complements. So the thing is, when you have sine and cosine, which are cofunctions, so when you have cofunctions and the angles are complements of each other, then these results are always going to be equal. So let's take an example here, a few examples, to see the types of questions that we might pop up here. So the first one says, they're telling me that sine of theta is equal to cosine of 35. So again, we have cofunctions that are equal. So that means the angles must be complementary. So I can take these two angles, theta and 35. We can add them together, and they must equal 90 degrees, because that's what it means to be complementary. So I can now solve for theta. So if I minus 35 from both sides, theta is going to equal 55. So in this particular question, theta would be 55. So sine of 55 degrees is equal to cosine of 35. Let's do it again for this one. So here again, check. I've got sine and cosine, which are cofunctions. They're telling me they're equal. That means I can simply take the two angles measures, add them together, and set them equal to 90 degrees. Once I do that, I can subtract them so that theta is equal to, and if I plug that in, what is that going to be? That's going to be 62.5 degrees. So this example 3, same exact work gets done. Again, sine and cosine. They are telling me they're equal. So in order for them to be equal, that means the angles must be complementary. Those two added together. So I can take each of them. So theta plus 20. It's an algebraic expression, but that's fine. Right? So this angle plus theta minus 10 all has to equal 90. Now I put them in parentheses just to keep them organized, but it's not necessary. There's no operation happening to them. So we can just combine like terms. So I've got theta and a theta here, so that's 2 thetas. I've got a positive 20 and a negative 10, so that's just going to end up being positive 10 is equal to 90. I have just a two-step equation here to solve, so if I subtract 10 from both sides, I get 2 theta is equal to 80. Divide each side by 2. We get theta to equal 40. Now the question could just simply say find theta or find the variable, right? Because again, I have theta here on these examples, but we could have x or a or some other variable. So that could just simply ask me to find out what theta or the variable is. Or it could ask me to go back in and figure out what the sine and cosine would have to be for these particular things to be equal. So if that was the case, I would plug this in. I would get sine of 40 plus 20 is 60. And that would be equal to, again, cosine of, if I plug 40 minus 10, that's 30. And again, you can check this sine in your calculator, and those two values would be equal to each other. So that's cofunctions. All right, in its entirety. Again, what you need to remember is that, first off, that sine and cosine are cofunctions. That's the first number one important thing. Secondly, in order for them to be equal, they must be complements with respect to their angles. Okay, and again, that's what this is stating here. All right, feel free to pause the video or rewind and go back and check anything over that you need to, and then we'll utilize this to practice more problems.